Let's look at the mechanism for a nitrile under acidic conditions. In this mechanism, be sure that you always look at the resonance. Whenever you get stuck, look at the resonance and see where the electrons are in the structure. In the first step, because this mechanism takes place under acidic conditions, we've got a lot of protons in our solution. So when we look at the resonance for the nitrile to start, we see that we have significant electron density on the nitrogen, we have a positive charge on the carbon, and that means that our nitrogen, under the conditions of the reaction, can easily pick up a proton from the acid in the reaction. Once the nitrogen does that, it makes the carbon a much better electrophile so that a molecule of water in our reaction can attack that carbon. We have another molecule of water come along to remove that proton and keep that carbon-oxygen bond that we just made intact. Now, this is the intermediate that we just have. And again, if we don't know what to do next in the reaction, let's look at the resonance. If we look at that resonance, if we take the electrons from the oxygen, push them towards the carbon, and then push the electrons over towards the nitrogen, we see that the nitrogen has a fair amount of electron density. And again, under acidic conditions, that means that that nitrogen can pick up a proton from the HCl or the H3O plus in our solution. At that point, once the nitrogen picks up that proton, we get to an activated amide structure. And we saw this activated amide structure in the hydrolysis of an amide under acidic conditions. So from here, the mechanism will proceed just like an amide did. And so that activated amide gets attacked by a molecule of water. We form a tetrahedral intermediate. We're going to remove the proton from the molecule of water so that that carbon-oxygen bond remains intact. We're going to pick up a proton on that nitrogen so that the NH3 plus becomes our best leaving group. And as our tetrahedral intermediate collapses, kicks out that molecule of ammonia, we get to this activated carboxylic acid at the end of the reaction. The final thing we need to do is to have a molecule of ammonia, grab that proton from the carbonyl, and that gives us our two products in this reaction. The mechanism for the hydrolysis of a nitrile yields a carboxylic acid and an ammonium ion. Remember that under acidic conditions, your carboxylic acid will be in the neutral form. Under acidic conditions, your amine molecule that we lost will be protonated. When we look at the mechanism for the hydrolysis of a nitrile under basic conditions, under the conditions of this reaction, we have strong nucleophiles. The only acid that we have available to us is a molecule of water. So it's not a great acid, so only very basic things will be able to take a proton from that molecule of water. So once again, if we start the mechanism by looking at the resonance in that carbon-nitrogen triple bond, we see that the carbon has a positive charge and the nitrogen has a negative charge. In the solution with that carbon, that is a good electrophile, we have a lot of nucleophiles. So those nucleophiles that we have will be attracted to that carbon. So if we have to fix the positive or the negative charge first in this structure, we're going to fix that positive charge first. Now we have this structure. And so under the conditions of the reaction, once that carbon gets attacked, that nitrogen, that N minus, is going to pick up a proton. The only proton source is water. Water's not a great acid, but that N minus is a pretty strong base, so it is an acid-base reaction that will happen under the very basic conditions of this reaction. Once again, when we get to this intermediate, what will help us understand what's going to happen next is the resonance. We have resonance in that carbon-nitrogen double bond where we can pull the electrons towards the nitrogen and reveal that we have a fair amount of electron density at that nitrogen. My carbon has positive character, and so I can attract the electrons from the oxygen toward that carbon. And that means that under the conditions of this reaction, in the structure that you see here, I have a positive charge at my oxygen and I have a negative charge at the nitrogen. Now, again, which one of these charges will be fixed first? Under basic conditions, it's likely that that proton from the oxygen is going to be removed first. And when that happens, that gives me the carbonyl with the negative charge on the nitrogen. Now my nitrogen can grab another proton from a molecule of water, and I have an amide. This amide is going to proceed through the rest of the reaction, just like our amide hydrolysis under basic conditions. So the hydroxide will attack that amide, will form a tetrahedral intermediate that will collapse, kick out that amide ion, and when we get that, we get a carboxylic acid and an amide ion. Remember that from that tetrahedral intermediate, the amide ion is not the best leaving group, but that is the group that moves us forward in this reaction. And what also helps this reaction to happen is that that final deprotonation of the carboxylic acid is irreversible. So this is the mechanism for the basic hydrolysis of a nitrile.